Hello everyone, I am Aishwarya Chavlia. Topic of my presentation is micro LED display. In this presentation, I will be talking about the overview of flat panel display, then the difference between the TFT LCD, OLED and micro LED display. Further, I will explain about micro LED display and its structure and also the method of production used for the micro LED display, followed by its advantages and applications. Flat panel displays such as OLED, LCD are the technology which are widely used in the markets for many applications such as wearable devices, smartphones, TVs, etc. Due to the new emerging technology for the flat panel display, micro LED display technology is also attracting more attention due to various advantages compared with the other flat panel display. This flat panel display technology is increasing as many companies have started the production of micro LED. The flat panel display is an electronic viewing device used to enable people to see content such as movie images, text, or other visual materials. Flat panel displays are lighter and thinner than the traditional cathode ray tube and are usually less than 10 cm thick. The first ever flat panel display was invented in 1964 at the University of Illinois. The flat panel display is divided into two types of display, emissive display and the other is a non-emissive display. In emissive display, the image is produced directly on the screen. Phosphor converts electronics beam or UV light into visible light. Example, plasma, CRT, LED and OLED. In non-emissive display, light is produced behind the screen and the image is formed by filtering this light. Example, LCD display. Structure of flat panel display. LCD stands for the liquid crystal display. Involves having a backlight usually fluorescent with an LCD screen in front of it. The LCD screen is where the images and the colors actually comes from. One of the drawbacks of LCD is that it can never produce true black because that screen would have to be completely opaque or solid in order to get true rich deep black. However, advantages of LCDs are that it is relatively inexpensive these days and unlike traditional CRT tube, they are extremely fair. The next display type LED is actually a bit no more because an LED display is just an LCD display panel with an LED backlight instead of cathode backlight. This gives a couple of advantages. Number one is a lower power consumption. Number two is even thinner form factor because they are not nearly as bulky. Number three is that with a many high-end LEDs array at the back, you can actually enable a feature called micro dimming so that it's just to say that the LCD goes black and the LED behind in that zone can turn down or turn as long as they can to make the black more true and much more rich. Plasma display have turned to be valued option over time. They have excellent black level because instead of relying on the backlight with a screen in front of it, the plasma display actually output its own light. You get extremely fast response time, making plasma greater for gaming. This advantage of plasma is that compared to a special high-end LCD or LED type display, the colors can be little bit washed out. If you are in a daylight or in the environment, you don't have to be a dark home theater to watch it all. And because the front of the display has to be the glass, they tend to give a fair amount of glare, making it more different again. OLED address same issues with the LCD such as the slow response time as well not very true to the light deep black because OLED like plasma emit its own light rather than relying on the backlight with a panel in front of it, but it is very expensive. Now we will look after the difference between TFT LCD, OLED and micro LED. The micro LED shares number of traits with the OLED technology, making comparison a little easier than LCD versus OLED debates. Micro LED and OLED are self-emitting technologies, so each red, green, blue subpixels produces its own light, unlike LCD which requires dedicated backlight. Therefore, micro LED display will offer very high contrast ratio and deep black just like OLED. The O in OLED stands for organic and refers to the organic material used in the light producing part of the pixel stack. Micro-LED technology changes this to an inorganic gallium nitride material, which is typically found in regular LED lighting. This switch also reduces need for polarizing and encapsulating layer, making panels thinner. The TFT is a thin film transistor liquid crystal display that is the technology to improve the image quality such as contrast. In TFT LCD, setup of electric circuit at the liquid crystal layer of TFT LCD would trigger transfer of molecules layer which coupled with the color filters and backlight source, endows each pixels three original colors red, blue, and green whose mixture creates a light in various colors. In the OLED, it is triggered by electric current. OLED can emit light in various colors by mixing the red, blue, and green light from its organic thin film, which is more vivid than a common LCD screen. Micro LED features miniature LED arrays, with each micro LED functioning as pixel and can be driven to emit light, with molecules becoming smaller, brighter, image quality and response speed improves. Now, what is micro LED display? Micro LED, also called as a MLED or Mu LED. Micro LED display is making LED structure thinner, smaller, and in an array structure. Individual micro LEDs usually ranges from 1 to 10 micrometer and are transferred in a large volumes onto the IC substrate. The substrate can be hard, flexible, transparent, or non-transparent. By using physical vapor deposition to complete a protective layer and forming the top electrode, it can be packaged into a simple structure micro LED display. Micro LED display offers the potential of wider color gamut, higher contrast, and deeper black than LCD and OLED display. As the demand for the higher and higher resolution display continues to expand, micro LEDs are poised to be the next breakthrough technology in the industry. About the structure of micro LED. The micro LED structure is a PN junction diode tube made of direct bandgap semiconductor materials. The micro LED is forward biased electrons from the semiconductor's conduction band recombined with holes from the valence band to release photons that emits a monochromatic colored light. In general, micro LED's maximum full width at a half maximum line width is 20 nanometers and can provide highly colored saturation of more than 120% of NTSC. Method of production. Due to their size, micro LED have required the display industry to develop entirely new production assembly technology. A micro LED screen is composed of millions of tiny pixels in chip form, each of which can be monochromatic or contain some combination of red, green, blue, or white subpixels. To fabricate a display, first, micro LED wafer must be created by a high yield epitaxial growth. Then each individual wafer must be transferred to a substrate or backplane that holds an array of units in a place. The transfer equipment used to place micro LED unit on a substrate needs a high degree of precision with a placement accuracy to within plus or minus 1.5 micrometer. In the chip bonding method, by splitting LEDs into micro-sized micro LED chip which includes epi wafer film and substrate, the micro LED chip can be bonded one by one onto the display substrate. In the wafer bonding, LED epi wafer film will use individually coupled plasma each to form a micro LED epi wafer film structure. Once this structure solidified, it will become the display pitch. Once the LED wafer, including the epi wafer and substrate, are directly bonded to the IC substrate, manufacturer will use mechanical or chemical processing to strip away the substrate, leaving the 4 to 5 micron thick micro LED epi wafer film structure that constitutes the display pixel on the IC driver substrate. In thin film transfer, using the mechanical or chemical method to strip away the LED substrate to replace it with a temporary LED epi wafer to form a micro LED wafer structure, then the substrate is removed using mechanical or chemical method and temporarily replacing with the other thin film. Then the display pitch required on the driver IC substrate uses selected transfer fixture to mass transfer the micro LED epi wafer thin film structure to bond onto a substrate and form into display pixel. In the in the pick and place method, growing the LEDs on a wafer, then producing the backplane that is substrate and the electrons, and then moving the tiny micro LED from the wafer onto the display electronics. This requires a fast, precise, and reliable process. Existing pick and place assembly its equipment can only achieve plus minus 34 micrometer accuracy, that is multi-chip per transfer. Flip chip bonding typically features accuracy of plus minus 1.5 micrometer but only for a single unit at a time, thus production speeds are slow. Neither of these existing LED transfer methods are sufficient for mass production of larger display such as TV screen, where millions of micro LEDs are required because traditional chip bonding and wafer bonding process don't provide efficient mass transfer for micro LEDs. The alternative monolithic method was introduced to overcome the complications of the pick and place method. Manufacturing times are also very slow and refinement is still needed to improve yield. JBD is developing a fabrication approach based on the monolithic hybrid integration technology that should be better suited to a small pitch LED for a very high density display. The general concept of technology is to transfer the functional micro LED epitaxial layer onto a silicon IC wafers. Shown in the figure, in the very first step, the wafer containing the micro LED epitaxial layer is bonded to the wafer with the IC circuitry. The next step is removal of silicon wafer substrate upon which micro LED epitaxial layer was grown. The result is an epi on IC structure that is then further processed using a standard wafer level semiconductor fabrication process. Following are the advantages of micro LED display. It has a high brightness. General brightness is around 4000 nits, but future iteration can produce a brightness of up to 10,000 nits. It has an infinite contrast. Contrast as in micro LED display is far higher when micro LED screen goes black. Its pixel produces no light. You can get darker than that. That means you can get an infinite contrast ratio. It has a fast response time. It is flexible and transparent display. It is self-emissive. It have a thin panel display. It have a longer time span because micro LEDs aren't organic. Hence, their lifespan isn't nearly as short as that of OLED. It does not suffer from screen burn due to different degradation rates of pixel. It has a better refresh rate because each pixel can be controlled individually. It has a lower power consumption. Micro LED requires no backlight. Each individual pixel is extremely energy efficient. Micro LED is used in many applications such as in the large panel display TVs, in portable projectors, in the wearable devices such as watches, in automotive such as in car TVs. It is also used in the biomedical devices such as near to eye display, and many more applications are in developing phase by many industries. To conclude my topic, micro LED is inherently more complex than LCD and OLED, promising new display technology with a high performance. The biggest companies and startups in technology hardware are moving forward with the idea. Micro LED could compete with OLED on a very high end of the market in various applications. Micro LED display may prove to be the next display technology of choice, and many display makers, including Sony, Apple, Samsung, and others, are developing the micro LED display. Sony is the first company to ship micro LED display, and that brings me to the end of my presentation. Following are the references which I have used in my presentation. Thank you.